Hi, today I have an 4ms typographic delay and it was sent to me by a customer claiming it was not responding to any tap inputs and no audio output. The moment I received it via the mail, I opened it up, had the smell, and it was in the bag. It's a little bit more faint now, but I could clearly smell what could be a blown component. Let's see if we can find out what's wrong with this machine. If it is blown in a way, I want to make sure first that we don't have any shorts and measure the resistance between so 6K on this side, that's the minus rail, 15K for reverse polarity protection, so that's why we not getting any reasonable reading because it's not passing through the diode. If we do it from here, on the other side of the diode, yes, there we go. So it doesn't appear to be shorted in this way, so I'm not afraid to turn it on. So I have my lab bench supply hooked up to this little board that I made to power Eurorack modules. So let's hook it up. With the bench supply I can limit the current that it's gonna deliver. It should be no more than 125 milliamps on the plus rail and 32 milliamps on the minus rail. So on the plus rail we get 150 milliamps and on the minus rail we get 50 milliamps maximum. Just in case there's something still wrong, we're gonna limit the current not to damage anything else. So let's turn it on. So yeah, that's working. And I haven't seen this unit before, so I'm not really sure how this module is supposed to work. So I'm gonna probably grab the manual at some point. But I would expect to have on. No LEDs or anything. So what happened here? We're drawing 30 milliamps on the negative rail and 70 milliamps on the positive rail. So something is running, but it could just be processor or... So let's measure some voltages where we can. There is a 5 volt available and also a 3.3. Looks like they're there. So let's probe some more. Well, would you look at this? I'm not sure. It was flashing, so it is responding now. It wasn't doing anything before, but I was looking for a clock and was probing some pins on the ARM processor to see if the voltages were there, and they were. Set up the default patch as is described in the manual. So as was stated, there was no sound coming from the module, but I just made the default patch as suggested in the manual, and the audio is just coming out of here just fine. So let's try to create a tab. And now it's suddenly... I was able to tap it a few seconds ago. Okay, let's power it down. So this is an intermittent fault, because I was just tapping it and it responded to my taps. Didn't hear any delay going on, but now I can't even tap it anymore. Well, the last time I got it working was by trying to see if there was a clock signal. And let's turn it on. Yeah, it's drawing more amps now on the plus rail. The clock is here. Yeah, I have a clock signal. It's drawing what it should be drawing. So in general, but let's do the necessary and have a look below the front panel. This is just sticked on here, but there's enough slag to get it out just a little bit. And maybe we can check the solder connections. Doesn't look well. Let's remove the front panel. Now we can have a look at the module. Are there any cracks in there? Gently put this back. This may be interesting. I'm not sure what I should expect from the touch sensitive element on the front panel, but this is what I measure. On one of the leads I measure 3.3 volts and it's steady. On the other I measure what now is going down back to 0, and then it floats a little at the end until it goes down to pretty much 0. Now let's see what happens if I tap it. Well, it goes to 3.3, but then it takes a long time. And now I also... So how about the voltages? Still 3.3. Oh, this is power coming in through the diode. I believe this was the 5. If I touch the pad on the front, nothing. Still 3.3 on the arm. I would guess that tapping gets buffered at some point before it's sent off to the rest of the circuitry. So maybe, I think these are op amps right here. So maybe one of those is not working as it should. So let me turn off the power again. Try to make a little schematic around here. I put the module under the microscope just to have a look around. I see some rework being done on one of the parts, but I can't read what's on there. So when put it on the microscope, and a visual inspection is always a good idea. Well, it had some rework done on it. That's obvious because there's a shitload of flux around the chip, and the soldering looks pretty hand soldered, but it's the audio codec. It's a Cirrus Logic C24271S. Yeah, CS4271. So I'm looking at the op amps around. Well, I'm not sure if it's op amps. Let's see if these are op amps. Yeah, these are 082 op amps. TL082. The soldering for touch sensor looks a bit, could be better, but it's making contact. Wow, someone has been here before as well. This op amp was replaced. Yeah, definitely. If this op amp is responsible for buffering the tap mechanism and it was replaced already, then there might just be another problem, because if the same component fails twice, then it's not only the component's fault. So I'm gonna put this under the microscope, do some probing if I can tell if one of the connections for the tap sensor is in any way connected to an op amp in the surrounding area. So yeah, I found a connection from the output of the touch sensor to the positive input, pin number 3 on an op amp, and it seems like it's configured as a voltage follower. So let's see what we can measure on the output of the op amp. Let's turn on the power, and now I think it's actually working again. Yes. So this is really intermittent. Sometimes it works, sometimes it doesn't, and this could very well be a bad solder joint or something like that. And now it's no longer working. What about the power rails to this op amp? Looks steady. This looks steady as well. What's coming out of the other output? That's pin 7. So the other side is only outputting 12 volts. Not sure what that's for. And this is the negative input. And the inverting input is attached to something. While I was trying to figure out how the circuit was hooked up, I put it under the microscope again, probe around some stuff. I just had this feeling like maybe the soldering is just not good enough, and it broke loose after a while. I just did some reflowing with some flux on some on the op amps and the surrounding circuitry, the resistors, and there's some caps over there. It seems like it's just a voltage follower configuration, but I was nearly done with drawing a simple schematic to see what's going on. And I did the reflow and I decided to give it another test, so I turned it on again and the power is as it should. The red light is burning again. So we have our dry signal coming in. And now clear it again. And now we're back to our dry signal. Let's turn it off again. Let's turn it on again. Immediately we have some sound. Previously whenever I cleared the pattern, it wasn't responding to tap inputs anymore. I think a little bit of reflowing did the job, in fact. So I'm gonna put it under microscope one more time. Have another visual inspection. It was not like any pads were not attached, because I used something to poke around and see if I could move the leads. Everything was connected, but maybe not electrically, so doing a little reflow can very often solve this kind of issues. So I just had another cleanup, went all around the board to see if anything else was suspicious. Amperage is what it should be. We're listening to the dry wet in the middle, and now I'll die off. So that seems to do the trick. Clean up the desk, and after I'm finished with that, I'm gonna give it one more try just to be sure that there's nothing else going on with this module. Maybe try out some more of the functionality. The problem description was no audio coming out, no response to the taps, and that all seems to be fixed. So I've been playing around with it a bit more, but I still think there is a problem, because supposedly the row of LEDs above here visualize how hard you tapped sensor. But I also think that it's only doing like one kind of pattern, one kind of interval. Well, you should be able to do different kind of intervals, not sync to a clock or anything. But look at how the LEDs are always fully on whenever I tap it. I cannot touch it soft. And now I want to also make another kind of rhythm where I do tap, tap, tap. But it's just doing the same interval. So I'm gonna hit up the manual to see if I can see anything about being at clock sync. Maybe it's on a certain setting, I'm not sure. When I measure the voltage coming from the sensor, it's still, whenever you tap it, comes to 3.3 volt and then slowly comes down, while I would expect it to be like tap down, but it's not. When I use the external tap input and I hook it up to a wire and I give it the same 3.3 voltage that is used to drive the sensor, I can make intervals or strange clockings. We can actually, you see how it's flashing in double sequences. Let's try it with the touch sensor. So how is that different? I wasn't really expecting the op-amp, the voltage follower, to be of a problem in this case, but I decided to swap it out anyway, and now let's try it again. It's velocity sensitive, and also it is getting burning hot though. The op-amp was definitely faulty because I can tap now. I can make rhythms, and we can even, it triggers every tap that I make is responding. But yeah, I don't think it was from the sun. I didn't solder it that long ago. It was only a matter of minutes. So it's turned off now, and I have well, let's take a little bit wider view. You can already tell that this part is getting quite hot, but let's turn on the power. You can see some op-amps getting hot right away. And immediately we're talking 80 degrees. We're already talking 90 degrees. And if we look at the other op-amps, we have some op-amps over here, and they only get like less than 50 degrees Celsius. And if we go back to the op-amp that I just replaced, it's already getting over 100 degrees Celsius. So it doesn't seem like the outputs are shorting. And now we measure negative voltage on the tap sensor. Well, it does respond immediately when I tap the sensor, and it's not drawing more amps than it should. Or does it? On the negative rail we're drawing, yeah, twice as much. It should be 32 milliamps and it's 60. So on the negative rail there's definitely a problem, which is pin 4 from this side. So I went for a walk, went around, clear my head a bit, because there's still something going on. This op-amp is getting way too hot, so it's shorting somewhere, delivering too much of power. Until now I've only been focusing on the one side of the op-amp because it's a dual package, and I've been focusing on the part which is buffering the tap input. But it could very well be that the other side of the op-amp is connected to circuitry that's draining too much power and causing the op-amp to fail, which in turn makes this fail. What else is this connected to? So that's what I'm going to focus on next, and see if I can make a little schematic to see what's going on and try to find out what it is that it is controlling. There is a sort of symmetry, but I'm not sure if it's there for the same purpose as op-amp 1 in the package. So that's what I'm going to do now. So I've been fiddling around with this module a little bit more, and what I noticed was that when I turn the power on, sometimes the negative rail is twice as much as is advertised. So it's over 60 milliamps instead of the 30/32 in my case here. I gave it another scrub with some cleaning and some IPA, and now it sticks to a nice solid 30 milliamps on the negative rail. I can turn it off as much as I want. It's pressure sensitive. It's still at 31 milliamps. So maybe there was still some, well, maybe it was flux, or maybe it was a little solder ball somewhere. I managed to find some points about the op-amp. The other side of the op-amp is for the velocity input, so it's a control voltage, and the tap input is connected together with the pad. Well, let's turn it off again and turn it on again. So there's an exact amperage on both reels. So yeah, I had my head against the wall for a while because I couldn't figure out why the op-amp was getting so hot, over 100 degrees. But yeah, it must have been some leftover from the soldering that fixed it. It's doing exactly as it should. I already had contact with the customer. He said it was not important that the tap sensor was supposed to work. He said as long as I can use the tap input, because he has other modules to insert. But I still wasn't satisfied, so I decided to replace the op-amp here anyway, because I had it laying around. And lo and behold, the op-amp was faulty. Kind of made a mess, so let me clean it up and do the final test. So, looks much better. Now for final run. Let's see if it all still works. That obviously sounds like crap, but that's life when you repair instruments. You have to listen to a lot of repetitive, annoying noises. Thank you for watching, and I hope I see you next time.